Good morning students. Today we are going to learn a new topic and very interesting topic, that is doubly linked list. So before starting the doubly linked list, we already have learned that is what are linked list, what are different operations that are performed on the linked list. So in our today's lecture we are going to cover the topics, that is introduction to linked list, what are the advantages and disadvantages of linked list. Whatever the disadvantages of linked list are there, these are overtaken by the doubly linked list. So before we starting the doubly linked list, we have to know the brief introduction about the linked list. Then introduction to doubly linked list, operations that are performed on doubly linked list, traversing, searching an element, inserting a new element to a doubly linked list, and deletion of an element from a doubly linked list. All these operations are similar to which are performed on the linked list. The difference is between the how these linked lists are doubly linked lists are structured and drawn in data structures. So and at the last of the topic we will discuss the disadvantages of doubly linked list. So let us start with the linked list. A linked list is a collection of nodes. Each node is linked to its successor node in the list using reference to the successor node. So in case of a linked list, it is a collection of, as we have noted that stacks is a collection of series of books or series of anything. So in case of linked list, we point a pointer which directly points to the node, which directly points to the memory location where the field or the element is to be stored. So one element, one entry is used for the address of the variable or element, and second part of the node stores the information or data which is required to store the information. For example, here is an example. We starts from the head nodes. At the head nodes we store the first address of the first node where the first node of the linked list is stored. 6 is the element or information, whereas 300 is the address of the next node of a linked list. With this we can point to the next where the next element is stored and directly points to the that node. So it starts from the head node and ends at the tail node. In above example, we have seen that at the tail node 700 position, 10th element 10 value is stored, and last is null. Null pointer indicates that there is no furthermore any node or element in this linked list. So whenever we start traversing, deletion or updation, we starts from the head node and it ends at the null pointer, that where null pointer ends no more nodes can be added or removed. So what are the different advantages of linked list to be used? So first of all, it is necessary to know in advance the number of elements to be stored in the list, and therefore need not allocate the as and when necessary. So first of all, if a node stores a element information as well as the successor element's address, so firstly we have to define how much memory space it is going to be take place. Then we can perform our operations, or we can allocate the memory to the linked list. So in a linked list, insertion and deletions can be handled efficiently without fixing the size of the memory in advance. So whenever we want to insert a new element or new node in a linked list, we have to find out the first location where we want to insert a linked list or node, or where we want to delete. First of all, find out the location, then we can set the successor pointers and move out the list with that. So an important advantage of linked list over array is that the linked list uses exactly as much memory as it needs and can be made to expand to fill all available memory location if needed. If as in arrays cases, we have already predefined the size of the array. Later on we cannot extend the size of the array, but in case of linked list we can use the memory as it needs. We can expand the memory and we can relocate the memory locations. So these are the advantages of the linked list, but there are different disadvantages that are created in the linked list. So first of all, the disadvantage of the linked list is wastage of memory. To store the successor memory address as well as information requires more space. For example, if we choose the particular size of the linked list but we have not used the full memory space, we have choose the 10 nodes but we are using only 5 nodes of a linked list, then we are wasting 5 nodes memory space. So this is the major drawback of the linked list. Second drawback of the linked list is no random access. No random access means we cannot randomly access each element. We have to start from either from the head to tail or from the tail to head. So this is the major disadvantage. Third one is time consuming, as we have to prefix the successor value as well as the information value to understand and to fill the new node and delete a node consumes the more time. So for linked list storage we need heap space restrictions, whatever the maximum value to be restored. So reverse traversing, that is if we want to traverse in linked list from the end of the node to the first of the node, then reverse traversing is very difficult in case of the linked list. So there are different types of the linked list that are available, that is one way linked list or singly linked list, in which a node contains two parts. One stores the element or information and second part stores the address of the next node. And in above example, as we seen the diagram, that is 12, then pointer is points to node 99 which stores the value 99, and pointer again moves to the node that is 37. This way of linked list is known as one way or singly linked list. Now two way or doubly linked list. Two way or doubly linked list has the two pointer variables. One first pointer variable, the first field stores the address of the previous node, and second field stores the address of the next node to be in the linked list. So next is the circular linked list. In case of circular linked list, the last node does not contain a null pointer. It again contains the address of the first node. So in this way it looks like a circular queue or circular linked list. So last one is header linked list. In case of header linked list, we use a header point and tail point. Header point contains the dummy head where no value is stored, and then the nodes are starts between the linked list. So tail indicates the last or null pointer, that is the here is the end of the linked list. So let us start with our topic, that is doubly linked list. A doubly linked list is a linked list in which each node contains a pointer to next node and a pointer to previous node. It is also called two-way linked list. That is why it has three fields. Let us say a element is stored. It stores the address of the previous node from which, and it stores the address of next node. So here three fields are used, that is forward, backward and information. Forward field stores the address of the next node. Backward field stores the address of the previous node, and information field stores the information or data. As in example, first is backward field, which store the address of the previous node from which it is connected, whichever the memory location where the previous node is stored, it stores the address of that node. 200 is information. Forward field stores the next node's address. In memory location, wherever it is stored, it stores the address and directly points to the next node of the doubly linked list. So forward field, it is the field that contains the address of the next node in a linked list. Whichever is the next node, it stores the address and points to directly to that node. Information field contains the information or data which is valuable or to be stored in a data structure or a doubly linked list. Backward field, the backward field is used to contain the address of the previous node in the linked list. So why it is known as doubly linked list? It is known as doubly linked list because it has two pointer variables, one is forward field and one is backward field. Forward field stores the address of the next node of the doubly linked list, and backward field stores the address of the previous node of the doubly linked list. So it points to the both previous and next node of the doubly linked list. In addition to above three pointer variables, head and tail are used that contains the address of the first element and the last element of the doubly linked list respectively. So in addition to these three pointer variables, we are going to use two pointer variables. One is head and second one is tail. So head pointer basically points to the first node of the or first element of the doubly linked list, whereas tail pointer points to the last node, that is last node or last element of the doubly linked list, and its forward field address contains a null pointer that no more nodes is connected. So the first element contains null value. If the first element contains the null value, indicate that there is no element preceding it, and the last element having null value to indicate that there is no element succeeding it. So it indicates whether it have forward any element or previous any element in a doubly linked list. Let us take an example. In this case, we are using the three pointers: first, last, information field, next field and previous field. In first pointer, the 1000 is stored. 1000 is the address of a element A, where A element or A node is stored. So in case of A node, first one contains a null value, that is the backward field contains a null value, indicate that no more previous node is there because it directly points to a element. 2000 indicates that the address of the next node to be attached with this link. When we go to 2000, it stores its first field stores, that is we are going to assess a B element. Its first field stores the previous node's address. What was the previous node's address? That is 1000, and B is the information or element which is value is stored in, and 3000 is the address of the next node. It does not contain 2000 because 2000 its own address, but it contains previous node address and forward node address. So 1000 is the address of the previous node where A element is stored, and 3000 is the address of the node where C element is stored. When we move on to the 3000 memory location, then C element is accessed and no more nodes in the doubly linked list. Then the backward field contains 2000, means previous node is stored at the address of the 2000, but forward field stores the null value. Null value indicates that no more nodes are connected in this doubly linked list. So last is the tail pointer, that is where it moves. Last element is stored at the location of the 3000 elements. So representations of doubly linked list. The doubly linked list can be represented by declaration in the memory, that is we have to first define the all the pointers, data fields and data field. So if we are going to use the C, then we are very much familiar with the structure programming. Let us say we are going to create a new structure, that is struct D node. D node indicate that doubly node. In structure we define whatever the pointers and whatever the fields we are used. First, struct D node star back. Star back indicates the pointer variable which points to the previous node. Int data element to be stored, that is maybe of type int, character or whatever type you want. Then again struct star forward. Star forward points indicate the whichever the next memory locations to be in the doubly linked list. So we have learned the doubly linked list. What are the advantages of doubly linked list over singly linked list? First of all is quick update operations such as insertion deletion at both ends. In case of doubly linked list, we can insert or delete an element from the both end as well as from the middle end. A node in a doubly linked list stores two references: next link that points to the next node in the list, and a previous link that points to the previous node in the list. So operations that are performed on the linked list, doubly linked list. There are four type of operation that can be performed on linked list as well as the doubly linked list. So these are, first one is insertion. Insertion is related to insert a new node, adding a new node to the existing linked list. If there is existing linked list, we can add a new node. The new node can be added either at the beginning of the node, at the end of the node, or in between of the doubly linked list. Next one is deletion. Deletions means removing a node from the linked list either from begin and or with given information. If someone gives the information that this information does not require, please remove that information from the doubling list, we can remove that information from that particular location without affecting the other elements. Next one is traversing. So traversing means to travel or pass across. We can say that visiting each element or node in a doubling linked list is known as traversing. Visiting each element and displaying its element value is stored in the node is known as traversing. And last one is searching. Searching means if someone have to find, gives you an element or a value that find out whether it is in the list or not, then we can perform the operations that is searching. Searching means to find out a particular element in a given list or to find out the location of particular element. So let us start with the traversing. Traversing doubly linked list can be performed in two ways, that is in order. In orders means starting from the head and ends at the tail pointer. So traverse a doubly linked list from the first element starting with the head pointer is known as traversing in order. The elements are traversed until the null value is not reached, as the head at the last node stores the null value. Forward pointer stores the null value. Until that null pointer value is not reached, it traverses the whole nodes. So traversing in order means starts from head pointer and ends at tail pointers. Let us start with the example of traversing in order. So it's very simple, that is we are going to start from the head pointer. So we have to check starts from the head pointer, we have to increment the each pointer to the next node and then find out whenever a null value is occurred, then we have to stop traversing these. So step 1 is begin traversing. First of all, set the pointer to the head because we are going to in order traverse. So in order traverse is head to tail. So whatever the pointer is declared, set it is equal to the head of the pointer. So repeat step 4 to 5 while pointer is not equal to null. If a linked list is of the 4 or 5 nodes, so it starts traversing the starting from the first node until the null pointer value is not come. So it repeats this step 3 and step 4, do the given task, and again at every step it sets the pointer to the next. So whenever first it checks condition, if condition is true, that is pointer is not equal to null, then it traverses and sets the pointer to the next pointer value. So these steps are repeat, 4 and 5 steps are repeat until the condition does not false, that is pointer is not equal to null. Whenever pointer is equal to null, the condition false, the program can be end. So next is traversing reverse order or tail order. Traversing a doubly linked list from the last element starting with the tail pointer. Traversing in order, reverse order is opposite to the in order, that is we have starts from the tail and then comes to the head of the pointer. So the elements are traversed until the head pointer value is not reached. starts from the tail pointer and the ends at the head pointer. So let us start with the example. In previous diagram we have noted that the a start node and the end nodes. Start nodes contains the backward field null value and end nodes contains the forward field null value. Backward field null value means that no backward there is no previous node is connected, and forward no next node is connected to the list. So if we are going to traverse in reverse order, then again the steps are same. The difference is that we have to check the previous pointer, not the next pointer. So begin, set the pointer variable to the tail, that is to the last variable, last pointers, last address of the node. Then repeat step 4 to 5 while pointer is not equal to null. The pointer is becomes equal to null when it comes to the first node of the doubly linked list. So do the given task. Every time whenever the condition is true, pointer is not equal to done, it check outs the element and it resets the pointer variable to the pointer to the previous nodes. So whenever it comes null, it stops traversing. That means the all the elements of the doubly linked list are traversed in the reverse order. So it ends at the search. So these are the algorithms for the traversing. Let us say we have to search an element in a doubly linked list. So to search an element in a doubly linked list can be traversed in any order. First of all, traverse either there are two, in order or reverse order. We have to find out the element start in order or reverse order. Before that, there are two types of doubly linked lists, that is, one is sorted doubly linked list and one is unsorted doubly linked list. In case of sorted doubly linked list, all the elements are sorted according to the, all the information or data is sorted according to the either top down or bottom up approach. In unsorted doubly linked list elements, data is stored whether it is in sorted form, whether it is in A to Z form or Z to A, whichever is form is corrected. So to search in a sorted list, we have to use the algorithm, that is, because it is unsorted. In sorted list we have to find out an element is easiest. Whenever element's value is matched, then we can stop searching the other list. So starts with the begin. Step 2 indicates the repeat step 3 while item head information and head is not equal to null and head information is not. Until the head information is not equal to item, then we have to repeat the step 3, that is, we have to change the head pointer to the next item. If it goes to the first node, it checks whether the element is there, then it's okay. If not, then again it moves to the next element. Whenever, if head info is equal to, whenever goes to head info is equal to item, we have find out the element, then go to step 5, that is return head. Whatever the value element, that is return the value, otherwise return null, that we have not find the element. Next is the algorithm for search in unsorted list, where the list is not sorted. Same, it is begin. So repeat step 3 while tail is not null and head information is not equal to. We have to search the whole list until the tail pointer is not equal to null and the head of information is not equal to item. If one of the condition get false, then this is that means that the element is found. So every time we have to change the, if the both the conditions are true, then step 3 is going on, that is the tail pointer, the value of the tail pointer is changed to the tail and previous. So whenever the any of the condition turns false, then it goes to the step 4. Step 4 returns the head value, whatever the element is we want to found. If found is, it returns the value. So it is the end of the algorithm. So next topic is insertion in doubly linked list. Insertion operations adds a new node in an existing linked list. to add a new node. If we have already a doubly linked list of 5 nodes, to add a new nodes means we want to move on to the 6 node doubly linked list. So a new node can be inserted in number of places in two-way linked list. Here we will discuss the following cases. Number one is insert new node at the beginning of two-way linked list or doubly linked list. At the beginning, that is the first node to be inserted. Second one, insert new node at the ending of the doubly linked list. At the end of the doubly linked list, the pointer variables to be changed. So insert new node into a sorted two-way doubly linked list. So insert new node at beginning. For this we have to change the address in start and back field of the first node. As current node, let us say new node is where the element 10 is stored, and the current node is the first node is 20th, where the current node is where the element 20th is stored. So basically the backward field contains the null value and forward field contains the address of the node where the 30th element is stored. So we want to insert a new node at the beginning. So first of all we have to move the backward field must contain the address of the node of the where the 10 value is stored, that is new node address, and the head pointer is moved to the where the 10 value to the new node. So basically head pointer now contains the, in the next step, head pointer contains the address of the new node, whereas the current node contains the address of the new node. So basically what is the algorithms to start? Other whole doubly linked list will be same, just change becomes where at the beginning of the node. So if start is equal to null, if head or start is equal to null means there is no node in a doubly linked list, then what will it do? It starts with a new node. Last pointer is stored the value of the start, and start information whatever item is to be going to be stored is stored. Start back is null and start forward is null, because we in if start is equal to null indicate that a doubly linked list with 0 nodes. So we are going to node 1. If we can add one node, then no more nodes are there, so it means that information is stored. Start back is null and start forward both are pointers are null. If it is not null, if start is not null, then set pointer, whatever the pointer is, it is set the pointer to the start, and then start the pointer moves to the new node, means the start pointer stores the address of the new node. Then starts pointer new node back is null, and information stores the whatever the value to be going to be stored in that new node, and forward pointer stores the address of the second node of the doubly linked list. These steps are going to be performed. If we want to insert a new node at the end of the doubly linked list, so there are 4 steps to add a node in a doubly linked list. First, check allocate memory for the new node. Determine the insertion point to be after. Determine the insertion point, whether we want to insert at beginning or whether we want to insert at the end of the pointer. So point the new node to its successor and predecessor, forward field and backward field pointers to be success. Point the predecessor and successor to the new node, and then for this we use the pointer variables last, which holds the address of the last node. With the help of last pointer we can insert new node at the end without traversing. So let us say last node or last, that is tail pointer store the last node address, that is where the element 40 is stored. We want to insert a node after the element where 40 is stored next to it. So new node, first find out the address, memory, allocate the memory location, and then the 40th node's forward field must contain the address of the new node, and the tail contains the address of the 50th new node. So basically in the end 2 pointers are changed. One is at the end of the node, that is which contains the forward field pointer, that is null value to be changed to the new node values address, memory address, and 50th previous field contains the address of the where the 40 element is stored. So basically these two changes can be performed, and tail pointers then points to the new node. So what is the algorithm to insert a new node at the end of the doubly linked list? If start is equal to null, again if start is equal to null, that means there is no node, not a single node in a doubly linked list, then that means we are inserting a first node of the doubly linked list. So start is equal to new node and last is equal to start. Then store the information, that is start information is equal to item, and start back is equal to null, and start